So we're on exam question 23 on page 583. And if you want to draw this curve on the calculator, we can start by entering, we can just write it exactly as it says, more or less, minus x squared divided by 10, and then multiplied with x minus 10. Just put brackets around that last bit there. And then you can draw. It may not look exactly like that. It depends on the view settings. But it says in this task that the area A is defined as the region bounded by the curve and the x-axis. So we're only interested in the part that is above the x-axis. It's bounded by the curve and the x-axis. So it's this area that we want. You can change the view settings. Well, it means that, well, there could be, you could be on a negative side of the x-axis, but you can't be on the negative side of the y-axis. Just set the x minimum to 5, the max to 20. The y minimum is set to -1 or -5. It's just to get, it's just so that you're able to actually see the x-axis. So I'll set it to -3, and then maybe 20. It depends how high it goes. Last time we found the maximum to be just under 15, so we'll let it run to 20. So once you have those settings, you can draw the graph. You can see from the graph that this function actually bends up like that on the other side of the y-axis, but it appears to cross the first axis around here. So that's why we don't worry about this part. We're only interested in this area that is bounded by the graph and the x-axis. First thing we want to do is find the intersection points with the first axis. So we can do that by gsolve, go to root, and that'll give us the first point, 0, 0, and just use the arrow here to go to the next one, which is 10, 0. So the zeros of the function is 0 and 10. And you can check that by just putting in these numbers in the function, and that will give you a function value of 0. Now, the next bit, when you are going to draw the curve, you need to have a value table of some sort. So you can set it up by hand, but there's an easier way. You can actually, if you go to the main menu again, you don't have to worry, you're not going to lose this. The main menu, and then go to table 7. It looks like you're back in the same graph menu, but it actually says table on top here. And then instead of draw, you can choose table over here. Aha. No. Right, so just make sure that the function is selected up here. There should be a white border around the equal sign, and then you can make the table. And you get a beautiful value table. You get a list of x's with whole numbers, which is exactly what you want. and then you can just enter these values into your plot and draw the graph that way. This list only gives me the first or some of the values, so I would like to have more values than this. So I've set this to start at 0 and end at 10, and with a 0.5 step, that means I'll get 20 values in my table.
Where did you find table set?
See, here, F5. Yeah. If I now print my table, I get more values here. So I'm sure you'll be fine just using the whole numbers, so 1 and 2 and 3 for most of the graph, but around the sharpest bends, you would probably want to have a few more points. So just use the points you need to draw a good graph. And the task tells you to sketch the curve clearly showing the area defined as A. So the more the better, but of course you're under a time constraint here, so you don't want to plot all the points, but as many as you need. So you probably need more points around here, around the top of the curve, because here it bends most sharply. And just to clinch this, make sure that you also have the maximum point. To find the maximum point, you go back into graphing, press Gsolve, and then F2 for max. So that'll give you the maximum point. And the maximum point is when x is 6 2/3. And that means that the maximum point, the highest point on the curve, is 14.8. So once you've drawn the curve, that's probably the bit that takes most time here. So it's important that you practice. So once you've drawn the curve, you move on to task B here. So this is our curve, y equals minus x squared divided by 10, and then x minus 10. And B, write down a definite integral that represents A. And again, we have this command term that you must be familiar with by now. Write down means simply, no calculation, just write down the answer. It requires you to know how to do this, but there is no real calculation involved. So write down a definite integral. A definite integral needs to have boundaries. So you need numbers below and on top of this symbol here. But other than that, it's just to put in the function inside here. So this is the equation for the curve. And then put this dx at the end here. The only thing missing now is the boundaries. And you know that this curve, since you've already drawn it, you know it has to go from 0 to 10. And that's the area function that we are interested in then. So the boundaries of the function, they go from 0 to 10 because this is the boundary for the area that we're interested in. So here x is 0, here x is 10. So we are calculating the area here. So that's the answer to B. Now, C. Find the exact value of A. I'll show you the quick and easy way to do this to get the answer. But that's not going to be enough here. But to get the answer to C, to find the exact value of A, we could simply, once we've drawn the graph, go into Shift F5 for G solve, and then press F6 to get more options, and then you have the integral symbol here. Just press F3, and it'll give you the area once you put in the boundaries. And the boundaries, they were 0, the lower bound, and then 10 would be the upper bound. And it's going to shade in the area for you and tell you what that area is. So 83.33333. Now that's simply the answer. And that would give you 1 mark. But question C is find the exact value of A. So we're going to do that. And it also says exact value. 83.333 is an approximation. So find the exact value. Of A, which is the area under the graph. So let's do that. And this will involve integration, which is the opposite of differentiation. So we have this expression here. And it's helpful to rewrite this into something we can recognize. So we would have to dissolve this parentheses. And that means, okay, we have minus x to the power of 3. I'm just multiplying with the x in here, divided by 10. And then I have a minus here and a minus here, so that's going to be a plus 10 times x squared divided by 10 dx. Again, I can make that simpler. So let's say that, okay, I want a number in front of my x. So I'll rewrite this as 1/10 times x to the power of 3 plus x squared. And now I'm ready to anti-differentiate. The notation for anti-differentiation, I haven't really seen it in the textbook, only in the answer key, but this is really the standard way of writing it. We use these square brackets instead once we leave this way of writing it. So once you start integrating, this is how you would write it. We have x to the power of 3, so we know we need to go to x to the power of 4. We have to multiply with 1 divided by 4, so that's 1/4 multiplied with negative 1/10. And then we have to add something x to the power of 3, and that's going to be 1 divided by 3 multiplied with x to the power of 3. If we differentiated this, you would see that from this you would get x squared. And then now we put the boundaries on the other side here. And that's it. And we can simplify it a little bit more. So this is going to be minus 1 divided by 40, x to the power of 4, plus 1/3 times x to the power of 3. And to score all the marks here, we actually do have to do this all the way out. And now it's going to be putting these values into wherever you have x, and then subtracting the other half of it. So we can write this as minus 1 divided by 40 times 10 to the power of 4 plus 1/3 times 10 to the power of 3 minus negative 1/40, 0 to the power of 4 plus 1/3 times 0 to the power of 3. This is all going to be 0, so we don't have to worry about that. So it's this part we're interested in. So we have 10 to the power of 4, that's 10,000, divided by minus 40, plus 1,000 divided by 3. And I would suggest that you use the calculator for this answer. Let's see. That's going to work out to be 250 divided by 3. Which is approximately 83.3. But this is an exact answer, and that's what the task asks for as well. Find the exact value of A, so find the exact area. Now, what I think is the coolest part of this really is that we can actually calculate by hand the area of an irregular shape like this. So, before we've only known how to do rectangles and triangles and circles, but we can actually find the areas of quite irregular shapes as long as we know the function of the curve around that shape.